Today, I'm talking about the definite integral. The definite integral can be expressed by the area between the curve fx and the x-axis, which were already discussed in the previous section. I will explain again. This is the x-axis, and this is the y-axis, and we have the curve f like this, and the curve A, this is x, and we would like to find the area from x equal a and x equal b. The area between this curve fx and x-axis. So we, in the previous section, already discussed, and we can find the area between the curve fx and the x-axis. We subdivide from x equal a to x equal b. Subdivide at the same base length, this delta x, and we can select the sample point. This is x1 and x2, and this is the function value at sample point xi is the height of the sub-rectangular. So this is the height is this, and this area and this. If the sample point is this, and the area is this, and total sum is S1 plus S2 plus etc. So we have already discussed in the previous section. So area between the curve fx and x-axis in limit n is approaching infinite, x1 star, x2 star, and xn star is the sample point. So if the sample point is located at left function value, it's called left sum, and if sample point is located at the right function value, this is called right sum. So this sample value is arbitrary. So this is the sum, the area S, and we can express this area with the limit and sigma like this. And this is called Riemann sum. And this Riemann sum can be expressed by this. This is called definite integral. When we change Riemann sum into definite integral, the sample point xi star changes. This is xi star change x, and xi star can this change fx, and this a is called a and b, and the endpoint of x. The a is called lower limit, and b is called the upper limit. This expression is called the definite integral, and xi star is x0 plus I delta x. Delta x is the base length, and x0 at this case x0 is a plus I delta x. Delta x is the same subdivision, so this is b minus a over n. So xi star is a plus b minus a over n I. So we can change this Riemann sum into the definite integral. So above it's called Riemann sum from a and b. This limit and sigma expression is called Riemann sum. And xi is sample point, delta x is base. Base is the same. So fx is called integrand, a is called lower limit, b is called upper limit, and delta x base length is b minus a over n equals subinterval, and xi is x0 plus I delta x. So if the function fx is positive, integration from a to b fx dx, this expression is called definite integral, becomes area bounded fx and x-axis. If fx is negative, then this definite integral is also negative. So the second is, if f is continuous on a and b, or function f has only a finite number of jump discontinuity, even if f is not continuous, the f can be integrable. So the definite integral can exist even if f is not discontinuous, but the finite number of jump discontinuity. So I will take an example. The first example is evaluate the Riemann sum for fx equal x cubing minus 6x. X is between 0 and 3, including 0 and including 3, with 6 subintervals. 6 subintervals means n equals 6, and taking right endpoint. The right-hand function value is the height of the subrectangle, so as a sample point. So we can draw x cubing minus 6x. This is x and x-axis, and this is y-axis. The intersection to x-axis to this function is x plus square root of 6, x minus square root of 6, 0 and square root of 6 minus square root of 6. The curve is like this. From x equals 0 to 3, the curve is negative. So we predict the definite integral is also negative. So this is when x equals 0 to square root of 6, the sixth interval, we have 6 subdivision between 0 and square root of 6. And so delta x is, this is 0 and 3, and like this. Between when x is between 0 and square root of 6, the function y equal fx is negative. From x is from square root of 6 to 3, the fx is positive. So delta x is 3 minus 0 over sub 6 and 1 over 2. So this is 1 over 2, 1 over 2, 2, 2, 3. So like this. We have 6 division. And this is 1 over 2. And this is 1, 3 over 2, 2. This point is 5 over 2. So we take the height as right hand function value. So this right hand function value is the height. So this and this and this, and right hand this, and this is this. And this is the S1, S2, S3, S4, S5, S6. So S is, Riemann sum is x1 plus S2 plus S3 plus S4 plus S5 S plus S6. This is Riemann sum. This is the base length is 1 over 2, and function value is f1 over 2 plus f1 plus f3 over 2, f2, f5 over 2 plus f3. This is the answer. So we can calculate this. The result is approximately minus 3.9375. This is the answer. The next question is, express this Riemann sum as a definite integral on 0 and pi. And this is when we change Riemann sum into definite integral, xi is changed x, delta x changed dx, the integration from 0 to pi, xi is x cubic plus x sine x, and dx. This is the answer. This is the answer. And next question is, evaluate integration, definite integral, integration from 0 to 3, x cubic minus 6x. So we cannot calculate this definite integral directly. We will discuss calculation, direct calculation for definite integral next time. At this time, we cannot calculate this directly. So we have to this definite integral into Riemann sum. So definite integral from 0 to 3, x cubic minus 6x dx. We can change this definite integral into Riemann sum. The limit n is approaching infinite, and sigma from I equal 1 to n. So x is changed xi, dx is changed delta x. So this is xi cubic minus 6xi delta x. So xi is x0 plus I delta x. So in order to know xi, we have to calculate the delta x. Delta x is 3 minus 0 over n. We don't know n, so n is 3 over n. So this is x0 n 0 plus I 3 over n. Yeah, this is xi. So Riemann sum can become sigma limit n is approaching infinite. Sigma from I equal 1 to n. Xi is I 3 over n 3 over n cubic and minus 6 I 3 over n. Delta x is 3 over n. So we have to calculate this summation. This summation is limit n is approaching infinite, and sigma I from I equal 1 to n. This is n 27. First term is 27 over n cubic, sigma n cubic I cubic minus this is 18 over n I multiply 3 over n. So we can, this is 3 over n, and we 3 over n, and sigma from I equal 1 to n, 3 over n, and 27 over n cubic, sigma from I equal 1 to n I cubic minus 18 over n sigma from I equal 1 to n I. So we have already known sigma I from I equal 1 to n I equal n multiply n plus 1 over 2 and sigma from I equal 1 to n I cubic is n multiply n plus 1 over 2 square. So this result input this Riemann sum. So we can find this is limit n equal approaching infinite. The limit n is approaching infinite, and this is 3 over n, 27 over n cubic. This is multiply n square, multiply n plus 1 square over 4 minus 18 over n multiply and n plus 1 over 2. This is cancel, and this is also cancel. So this is a limit n is approaching infinite. This is 4 n over n square, n multiply n is n square, and this is 81. 3 multiply 27 is 81. 81 is n plus 1 square minus limit n is approaching infinite 2 n over 54 n plus 1. So this is 81 over 4 minus 27 to 54 over 2. This is 481 minus 108. This is minus 27 over 4. This is the answer. The next example is express definite integration. Integral from 2 to 5 x to the power of 4 dx as your Riemann sum. So when we change the definite integral into Riemann sum, the x is changed xi, and dx becomes delta x. So this is this can be limit n is approaching infinite sigma from I equal 1 to n. So x is changed to xi to the power of 4. The x changes delta x. Delta x is the end point is 5 and starting point is low point is 2 and n. This is 3 over n. The xi is sample point is x0 plus I delta x. x0 is 2 plus I multiply 3 over n. So this Riemann sum is limit n is approaching infinite sigma from I equal 1 to n 2 plus 3 over ni to the power of 4 multiply delta x is 3 over n. This is the answer. This is the Riemann sum of definite integral from 2 to 5 x to the power of 4 dx. The next question is evaluate two definite integrals. First is 1 square root 1 minus x squared dx. So we need to change this definite integral into Riemann sum. So x is can become xi, dx become delta x. So this is the limit. N is approaching infinite. Sigma from I equal 1 to n, and square root 1 minus xi squared delta x. So delta x is end point is 1 and starting point 0 and n. Xi is 0 plus I delta x is I 1 over n. So this Riemann sum becomes limit n is approaching infinite. Sigma from I equal 1 to n square root 1 minus 1 over ni square multiply 1 over n. So calculating this summation is very difficult. So maybe impossible. So we take another method. What is the meaning of definite integral? Definite integral is integral and Riemann sum. This Riemann sum, meaning of this Riemann sum is the area between the function 1 minus x squared and x-axis. So we can draw this function. This function is, this is x and this is y. This area, this is this area. This is the radius is 1. So this area is pi over 4. This is the answer. This is very easy. If you can graph this curve, this is very easy. You don't need to the Riemann sum in order to find the area. So second question is integration from 0 to 3 x minus 1 dx. So we can find this definite integral, not to express the Riemann sum. This is we can draw the y equal x minus 1. X minus 1 is minus 1. 0 to 3. And this area is minus 1 over 2. This area is 3 and 2. 2 multiply 2. This is 2. So this is 2 minus 1 over 2. So this answer is 3 over 2. If you change this definite integral into Riemann sum, the result is the same. So next topic is the midpoint rule. Midpoint rule means we select the sample point is between xi and with the midpoint between xi and xi plus 1. So this is I will take an example. So this is x and this is y, and like this. Curve is this. This is for example, this A is this and B is this. When I will n subdivision, take a n subdivision, and the base length is the same, delta x. The x is end point minus starting point over n, and the height we can select the height, the function value of the midpoint, and xi and xi plus the midpoint, and this is the height. So the sub-rectangular area is this area, and midpoint, we select the midpoint, and this area is sub-rectangular area. So we take a midpoint like this, and midpoint like this. So this Riemann sum is called the middle point rule. So delta x is b minus a over the upper limit, the end point, and lower limit, the starting point over n. And sample point is the midpoint and xi minus 1 plus xi over 2. So I will take an example. So use midpoint rule with n equal 5 to approximate integration from 1 to 2, 1 over x dx. So we change this definite integral as Riemann sum. To 1 over x dx. So limit n is approaching infinity sigma from I equal 1 to n. So x becomes sample point xi, 1 over xi. Dx becomes delta x. So delta x in midpoint rule is this is 2 over this is n over endpoint minus starting point, and 1 over n. And xi is x0 plus I delta x. X0 is 1 plus I delta x is 1 over n. And midpoint is xi plus xi minus 1 over 2. So x0 is 1. X1 is 1 plus 1 over 5, 6 over 5. And x2 is 1 plus 2 over 5, 7 over 5. And x3 is 1 over 3 over 5 and 8 over 5. And x4 is 1 over 4 over 5, 9 over 5. x5 is 1 plus 1 equal 2. This is A and this is B. And x1 bar is 1 plus 6 over 5 over 2 and 11 over 10. Midpoint between x1 and x2 is 6 over 5 plus 7 over 5 over 2. This is 13 over 10. The midpoint between x2 and x3 is this is 7 over 5 plus 8 over 5 over 2. This is 15 over 10. The midpoint between x3 and x4, 8 over 5 plus 9 over 5 over 2. This is 17 over 10. The midpoint between x4 and x5, 9 over 5 plus 2 over 2. 9 over 5 plus 2 over 2. This is 19 over 10. So the area, the definite integral is the Riemann sum. The Riemann sum is the base is 1 over 5, and it's f. The midpoint is 11 over 10 plus f, 13 over 10 plus f, 15 over 10 plus f, 70 over 10 plus f, 19 over 10. This is the answer. The effect, this is fx. Integrand is 1 over x. So calculating this and approximated 0.6919. So I will express the graph. So we can draw a graph. This is x and this is y. And this graph is y equal 1 over x. This is 1. It's 1 and this is 2. And subdivision is 5. 5 is 1, 2, 3, 4, 5. This is 2, and 6 over 5, 7 over 5, 8 over 5, and 9 over 5. So we can take a midpoint. The Riemann sum is we take the midpoint and this is rectangle and midpoint. And no, this is a you can midpoint and height is this, and midpoint point height is this, and midpoint height is this. This S1, S2, S3, S4, S5 is the Riemann sum, and it is definite integration from 1 to 2, 1 over x dx. So next topic is property of definite integral. The major property fx and gx are continuous functions as z is constant. Integration from b to a fx dx is if we exchange lower limit and upper limit, and this is the minus 1 must be multiplied. So if lower limit and upper limit are the same, this integration is 0. If integrand is the constant, the c and upper limit minus lower limit. And this is the linearity of integration, and this superposition characteristic, and this is also linearity property. And this is integration a to c. If the integrand must be same, the a and b. This is integration a to c and c to a. This is the property of integration. We have already known. So I take an example. Evaluate integration 0 to 1, 4 plus 3 x squared. So in order to evaluate this definite integral, so we need to change this definite integral into the Riemann sum. So the Riemann sum is limit n is approaching infinite, sigma from I equal 1 to n, 1 to n, and 4 plus 3, x is changed, xi, sample point xi, square, the x changes delta x. So delta x is endpoint and starting point over n. Xi sample point is x0 plus I delta x. X0 is a low point is 0, and this I multiply 1 over n. So it can be limit n is approaching infinity sigma from I equal 1 to n, 4 plus 3, 3x. 3xi, xi is a square, and delta x is 1 over n. So, right, we can, so Riemann sum is, limit n is approaching infinite, sigma I equal 1 to n. This is 4 plus 3, n square over I square, 1 over n. This is the limit, n is approaching infinite, 1 over n. And this is sigma from I equal 1 to n 4 plus 3 sigma. This is 3 over n square. Sigma I from I equal 1 to n I square. We have already known. So sigma from I equal 1 to n I square is n multiply n plus 1 multiply 2n plus 1 over 6. We input this formula into the Riemann sum. So Riemann sum is, this is the Riemann sum. Limit n is approaching infinite, 1 over n, and 4n plus 3 over n squared multiply 6 and n plus 1, 2n plus 1. So this is cancel. And this is this multiply, this is 4 plus limit n is approaching 0, 6n squared, 3n plus 1, 2n plus 1. This is 1, so this is 5. The answer is 5. The next example is, we have already known this is definite integral and this is definite integral. So it's definite integral from 0 to 10 fx dx is integration from 0 to 8 fx dx plus integration from 8 to 10 fx dx. We have already known this is 17 and this is 12, and our purpose is to find this definite integral. So the definite integral is 5. The answer is 5. And next topic is comparison property. If function fx is greater than 0 on a and b, and integral from a to b fx dx is positive, greater than 0, and if fx is greater than zx on a and b, integration from a to b fx dx is greater than integration a to b dx. It is natural. And if fx is continuous, fx is extreme value theorem, and it means fx have minimum and maximum value. So fx is minimum value m, has minimum value m and have maximum value large M. So this integration is satisfied because we take integration from a to b and both sides. Fx dx and m, integration from a to b, large M dx. So this integration can become this integration become this. So this inequality is satisfied. So we take an example. Estimate the range of integration 1 to 4 square root x dx. So integration 1 to 4 x dx. So this definite integration means the area between the curve square root x and x-axis from x equal 1 to 4. This is we can draw the curve square root x. This is x and this is y. This is square root x equals 0 to 4, and this area is definite integral. This area is 1 to 4. This area is greater than this area. And less than this area. So this area is greater than this area 3 and 3, and this big rectangular is 3 multiplied and 4. This is 2 multiplied 2 and 6. So this is the answer. This is the answer for this question. Today we discussed about the definite integral, and at this section, to calculate definite integral, we have to change the definite integral into the Riemann sum, and we calculate the Riemann sum or the area between the curve and the x-axis. So next time we will study how to calculate definite integral directly. Thanks for listening to this video, and see you next time. Bye bye.